Hello! In this video, we are going to prove the following theorem. Suppose f is a function from a to b. Then, f is surjective if and only if the range of f is equal to b. So first of all, what does it mean for a function to be surjective? Well, if you recall, f is surjective if for every element b in B, there is an element a in A such that b equals f of a. And second of all, what is the range of f? Well, by definition of range, if you recall, it's the set of all elements b in B, such that there is an element a in A, such that b equals f of a. So as you can see, these two look really similar to each other. So this theorem may not seem like such a surprise, but let's prove it. So we're trying to prove a statement containing if and only if. So what we're going to do is we're going to prove if this is true, then this is true. And then we're going to prove if this is true, then this is true. Let's start by proving if this is true, then this is true. And to do so, assume this is true. And our whole goal now is to deduce that the range of f is equal to b. So really, we're trying to prove that two sets are equal. So what we can do is we can show that the range of f is a subset of b, and b is a subset of the range of f. Now, by definition of range, it immediately follows that the range of f is a subset of b. Because if you consider any element in the range of f, well, then that element is an element of this set, which means it's an element of b. So yeah, by definition, the range of f is a subset of b. So now, all we got to do is show that b is a subset of the range of f. And to do that, give me an arbitrary element in b. I'll call it b. And now, we can use the fact that f is surjective. Because f is surjective, we know for a fact that this statement is true. And this statement works for every element in B. So it must work for the B that we have in our proof. Which means we can conclude that there is an element A in A such that B equals f of A. But now, B satisfies all the requirements to be an element of the range of f, right? Because in order to be an element of the range of f, first of all, you need to be an element of B, which we already have, and you also have to satisfy this property. But we just proved that B satisfies that property. So B is an element of the range of f. So at this point, notice we started with an arbitrary element in B, and we deduced that same element is also in the range of f. Therefore, B is a subset of the range of f. So, we've proven that the range of f is a subset of B, and B is a subset of the range of f. That implies that the two sets are equal. So now, we have proven if this is true, then this is true. So now we're going to prove if this is true, then this is true. And to do so, assume this is true. And now, our goal is to deduce that f is surjective, which means we want to prove that this statement is true. And we're trying to prove a statement about every element in B, so give me an arbitrary element in B. I'll call it B. Now, because B is an element of B, and B is equal to the range of f, this means that B is an element of the range of f. What does it mean for B to be an element of the range of f? It means that B is an element of this set. So really we have that B is an element of B, which we already know, but also B satisfies this property. So we can conclude that there exists an element A in A such that B equals f of A. So starting with an arbitrary element B in B, we proved that there exists an element A in A such that B equals f of A. Since B was arbitrary, this means for every element B in B, we have that there exists an element A in A such that B equals f of A. So we have proven precisely this statement, which means we've proven that f is surjective. And so now we have proven if this is true, then this is true. And we've proven both parts of the if and only if, which means we've completed the proof. And so yeah, this is pretty much one way in which you could prove this theorem. And yeah, that's pretty much it for this video.